I really want to bring in one of our product experts to actually demonstrate how these functionalities come together to create a seamless end-to-end data modeling process. Shaheryar has been one of the leading lights on the development team, helping to put together the product we're talking about today. And I think he's probably in the best position to answer our questions about the platform and what it can actually do. Hi, Shaheryar, with us? Hi, Shaheryar. So I wanted to start by talking about the actual initial design process. So let's say we're starting with a sales database that's mainly used for transactional processing. How do you go from there to a functional data model?
All right. So first of all, I'd like to thank you, Adnan. It's a pleasure to be here. So let me go ahead and move to the product itself. Can you guys see my screen?
Yep, you are visible.
All right. So right now I have Data Warehouse Builder open in my screen. On the right hand side, you can see the Project Explorer. At the bottom, we have some other windows such as job progress verification. And on the left hand side, we have other options such as the toolbox. So to um, begin with building your data warehouse, first step is to create a data model. And I already have one data model created here, a blank data model. So the first step inside this data model is to reverse engineer a source database, which you just mentioned, a sales database, for example. So here you can see that there are some options, there are some display options and some other features as well. But for our concern, the most important option is this reverse engineer icon. Let's click on it. So a wizard has opened, as you can see, and if I click on this ellipsis icon here, you can see that I can specify a database connection here. So right now it's pointing to my own machine and it has a database selected. But you can choose a different data provider here, for example, Azure's Azure SQL Server or Oracle or even open source databases such as Postgre, MySQL, and there are like 40 plus source connectors which you can connect to fetch the metadata of the database. So in this case, I'm going to continue with SQL Server as my data provider. I'm going to provide my credentials and then select my database from this drop down here. And I'm going to just press OK. So as you can see, it has listed down all the tables which were present inside this database. All the tables are present here along with their schema names. And I have different options here to filter out tables, but in this case, I want all the tables to be reverse engineered. A reverse engineering basically mean to convert the database tables into a visual format, which I can see and I make changes to it using GUI instead of going and writing scripts to make changes to it. So in this example, as you can see, I'm inside a view, but instead you can see that in my main window, all the tables are now reverse engineered. All the relationships, which are mainly the foreign keys inside the database, are also reverse engineered. So I can see how tables are connected to each other, and I can also see which tables were present in the database. Apart from that, if I can change the different options. I have different options such as view entities and keys, so I can see how using which keys the tables are connected to each other. And I have other options as well, which says view entity in all elements, but this can clutter the view a lot for me right now since there are too many tables inside the database. So I'm going to stick with this layout. If I go inside any particular entity, for example, buying groups, I can see some options such as table name, it's a schema inside the database, and we'll come to this entity tab later. I can also see its physical fields, which are reverse engineered here. I can see its name, its data types, its length, and its other such properties such as default values and whether it allows null or not. And on the third screen, I can see the indexes which were present inside the database, which were created in this particular table. So I can also add or remove indexes from here as well. Cancel out of here. And about relationships, so you can see that there are so many relationships in this data model. But if I select and double click on a relationship, its properties will open. Now, here, this is basically add to relationship wizard where I can see its constraint name. This is mainly the name which was the name of this foreign key relationship inside the database. And for simplicity, we have other options as well, such as this parent alias and child alias. Mainly, these are used for navigation purposes when you are designing your pipelines. And we have some other options as well, such as what's the relationship type here, non-identifying or identifying, and other properties such as if it's mandatory or not. From here, we can select which field in the child table it's going to connect to with, and we can rename the field from here as well. But I won't do any such thing here, and let's just cancel out of here. What's more important is that this data model right now seems really cluttered. So we can create some views from it. I have one view created already. You can do so by just clicking here, add new view. And inside this view, this is a brand new view, so it doesn't have anything in it yet. I can just right click anywhere and say add existing entities, and I can add any of the entities from my main window inside this view. So I already have one sample created for you, and I also have some views created in it as well. I have one view created for orders view and one view for sales, which I'm going to further modify to become a star schema. Over to you.
So now you've built this essentially this model.
Mhm.
How would you go about verifying it and then moving to deployment? So these are key features of our product. Can you talk us a little bit through these functionalities and how you get from there, from where you are?
Mhm. All right. So about verification. So there are we let the user make modifications to his source schema. He can add new fields. If I go inside any of the entity, I can add new fields here. I can change its data types, lengths, and I can also create some new relationships here using these relationship maker items. So I can make changes to the model, but there are certain cases where user make invalid changes, which are not supported by the data provider. For example, if I go to this copy sample, if I go inside the buying groups, um, a user accidentally entered wrong length in buying group name, for example. Now, this is not a valid change, and this cannot be forward engineered. This cannot be replicated in the database. This is an invalid change. So, what verification does, if I click on this verification icon, it will just start reading the schema and the entire data model, and it will look for any such verification errors. And if there are any such verification error, it's going to throw me an error that hey, invalid length. And as you can see, the context is buying groups. It's an error, and it's also telling me that what the error is, and it's also providing me a suggestion. So how verification works is it goes deep inside the data model. It goes into each of the entities. It checks for the data types, its lengths, its other properties, even its indexes, and tells us exactly where the error is. So it helps the user a lot when he is designing his data model.
That makes a lot of sense, Shaheryar. So basically, what we're talking about is saving hours of effort at the very least in like manually identifying and resolving these issues, and it's all boiled down to essentially single click functionalities within this product. So you're going to go back to that idea again of cutting down time, and this is really a key way of doing that, cutting down time. So we've got this done, and it seems like we're now ready to hit launch on the actual data warehouse. My question is, how do we get from what we have here, essentially an ER model, to let's say a dimensional star schema?
Right. So to build a dimension star schema, first I'll have to decide what in my star schema is going to be contained. For example, in this case, I'm going to focus only on my sales tables. So I have a view here, the view 2, which focuses on the tables which are useful for sales team. And I'm going to just go ahead and copy this and paste it inside a new data model, which I have already done here, star schema.mdl. I already have these entities copied here. These are just copied and pasted. Right. Now I want to merge some of these entities since star schema is denormalized to reduce the joins and efforts when running the queries. So I want some entities to be denormalized and I want to add some additional fields inside the dimensions. Whichever entities I'm going to pick as dimensions, I'm going to add some fields here, such as the surrogate keys, and I want business keys as well. And since I'm going to configure it for slowly changing dimensions, then I might need record identifiers as well, such as current record identifier, effective or expiry date, and so on. So let me go ahead and demonstrate it in front of you. So I'm just going to select invoice lines and invoices. I have selected both of these and I want these to be merged. So I'm going to go ahead and click on this denormalize icon. Once I click on it, its relationships are still contained, no relationships are removed, and the entities are now merged. If I go inside it, you can see the fields are now merged. My next step would be to choose the fact table inside this star schema. And of course, invoice lines is a good candidate for that since it has all the measures and the days which I need. I'm going to go ahead and mark invoice lines as a fact table. And of course, now the next step would be to mark my dimension tables and add some surrogate keys and record identifiers in each of the dimensions. But we are going to automate that process, and I'm going to just go to this data model button and say build dimension model. So right now it's going through all of the data model entities, and inside each of the entities it's going to add some surrogate keys, effective dates, etc. And it also added a date dimension here as well. So let me go ahead inside any of these entities. So for example, if I go inside this stock items entity now, you can see that entity type is now selected as dimension. If I go next, you can see that a new field is added. That's and that is marked as surrogate key. So one more thing. Now I see one more column here. Dimension role column. Previously, when the entity type was general, we don't see it here. But since it's now a dimension, we have this dimension role column here, inside which we can configure its roles. So for example, I want stock item ID to be my business key, and my stock items key, which I added a new field to be my surrogate key, and it's also system generated now. It automatically added an effective date here as well, and also marked a placeholder record as well. And this placeholder record, the purpose of this placeholder record is to handle late arriving dimensions or early arriving facts. So let me cancel out of here. Yeah, go on.
Sure, you talked about surrogate keys, business keys, early arriving facts, but for my money, handling slowly changing dimensions is probably one of the most complex parts of the dimensional modeling approach. What functionalities do we have in place to handle this task within the product?
Sure. So when we talk about slowly changing dimensions, it's pretty hard to handle slowly changing dimensions, especially when you are talking about slowly changing dimensions 2 or slowly changing dimensions 3 or 6. So what happens is you need dimension lookups when you are inserting data into your fact tables, and that can be a cumbersome task because it's kind of hard to write queries, and such long queries are really hard to debug when when you are writing queries for your ETL, and that takes around 40 to 50%, I would say, of the time of the ETL designer just to identify and clear out the errors. So if I go back into any of these entities, let's say customers, what's next? I already showed you its dimension role for business key, surrogate key, effective date, but we have some other roles as well. For example, I want this customer name to be SCD2. We now support built-in STD 1, 2, 3, and 6 mechanisms. That means you just have to mark the field whatever STD role you want it to play. You just have to mark it here. And when you are writing the ETL queries, it will it will not it will automatically handle it and you won't have to write long queries to handle the slowly changing dimensions when you are either updating your customer's dimension or you are inserting data into your fact tables. In both cases, you won't have to write long queries to manage your dimensions. It will automatically be handled by data warehouse builder. So I can mark one field as CD2, I can mark other as SCD1, and so on and so forth depending on my need. I can mark the fields, and that's all.
Awesome work, Shaheryar. I think that really just goes to show how powerful a product that this is, where we're taking, tasks that could, take up 40 to 50% of the time spent in data warehousing, as you just mentioned, and shrink that down to simple configurations in these entities. So now we essentially have the dimensional model built. But before we move forward, what type of verifications are going to be performed to validate this model?
Right. So about validation for we previously talked about the validation for a data model design, but when we talk about a dimension model design, now we need a different type of validation. Now verification is not in the verification which tells us about the data type mismatch, the lens is not in. Now we need some design verifications as well. For example, if a user is using slowly changing dimension 2 in a dimension, but he forgot to add a system generated field, which is going to be a surrogate key, it's going to cause an error in the runtime. And by the time the user identifies it, it's already been too late. He has already spent so much time designing his data dimension model, and by the time he's done with writing EDA queries, then he realizes, hey, I forgot to add surrogate key, or I forgot to add the row identifier, and other such. Well, I'm talking about really small issues here, which people don't usually forget, but there can be bigger issues than this as well. Just for demonstration purpose, I'm talking about these. So for example, if I go into this configure the MDL, and if I did not have any surrogate key, let's suppose I just go ahead and delete this row. So I don't have any surrogate key now, but I am using SCD2. And now if I verify it, it's going to throw an error that, hey, it should contain a surrogate key because it is using SCD2 or SCD6 fields. Does it make sense?
Okay. Yep. I think that made a lot of sense. Very well described. I think we're pretty much at the end of this process here. We have the schema design ready to go. One step left. How do we get from replicating the schema in a physical database?
All right. So once you have made all the changes here, you have added new fields. I also added a new entity called date dimension, which was added by the product itself, by the way, and that was to slice and dice your fact tables with respect to date. So I added a new entity. I made some changes to the relationships. I renamed the foreign key relationships, and maybe I renamed the schemas as well, the schema names as well. So there are so many physical changes which I have made inside this data model, but they are not yet forwarded to the database itself. For that to be done, I'll have to just go ahead and click on this forward engineer icon. And what it will do, it will replicate all these changes inside the database. And at the end, my database and this data model will be in sync.